Hello and welcome. In this video, you will learn how to read your own network datasets into UCINET. In particular, you will learn one of the data formats in which you can put together the data that you have collected when collecting network data in order to use in UCINET. You will also learn one of the data formats that you can use when collecting attribute data for your networks in order to use in UCINET. Then you will learn how to read this data from these self-collected networks into UCINET and how to read data from self-collected attributes into UCINET. Let's get started. So first of all, let's look at how you can collect data. So UCINET and network data in particular, or specifically, rely on the notion of matrices. That means that when you are doing your surveys, when you are collecting your data, then you will be required to process this information and to depict it into the form of matrices. How do these matrices look? Something like this. Here's an example of a friendship network that I collected. The nodes are John, Frank, Susanna, and Joyce. And the question that was asked to them is to indicate if they are friends with somebody from this group. A 1 indicates there's a friendship, and a 0 indicates otherwise. So once this question is asked to everybody, your first step is to represent this information in the form of a matrix, where you indicate in a column, the first column has the labels of the nodes, so the ID that you will use to identify every node in your network. And every column has to also identify the same individuals. You have to keep in mind that the order of your actors in your first column has to be the same order as your actors in your first row. So we first have John and John. Then we have Frank, Frank. Then we have Susanna, and last we have Joyce and Joyce. This is very important. It is also very important that you indicate on the very first cell the word ID. This tells UCINET that these names here represent the IDs of the nodes. Another thing that is very important is that if you're going to be using names for identifying your nodes, your names have to meet a certain criteria. One is it can only be one word. So you should not have a node ID called John space Smith. Otherwise, UCINET will take the word John as a label and Smith as information about the network. Alternatively, what you can do is combine them into one name with an underscore. But then you have to make sure that the names are consistent across all your labels. Let's just go back and keep our original name. Preferably, if you can, you should use numbers as IDs. This is just better also for data management processes purposes. So if you could instead of using John, Frank, Susanna, and Joyce, give it a name of 1, 2, 3, 4, and that would be your ID for your nodes, that would be even better. So in this network, as I said, it's a friendship network. 1 indicates that any 2 people are friends, and 0 is otherwise. Then we also collected information about their characteristics or attributes. And that information is preferably collected in the form of a text file. And what it is important is that the first row of your text file, of your attribute file, has to contain this piece of text. So it has a star followed by node space data. This line is telling UCINET that anything after this has information about every single node contained in your network. Now you see we have the label ID because this tells us that everything underneath ID corresponds to the IDs of every node. These names have to be exactly the same as the names that our network file also has to be the same names and the same number. So if for some odd reason your network has 4 actors and your attribute file has 5, then UCINET is not going to like it and you're going to have an error. So you just have to make sure that you have attribute information for the same nodes and the same number of nodes that are contained in your network file. As we learned in our previous video, attributes can be anything that tell us about the characteristics of our nodes. In this case, this attribute file contains information about the ages of the nodes, the gender, whether they're married or not, and their hometown. Now, let us read first, the network file into UCINET. As you learned from previous exercises, UCINET works with double hashtag H files. So that means that if we would want to read an Excel file into UCINET, that is not going to work. So we need to transform this Excel file into a readable double hashtag H file that UCINET can work with. How to do that? Then we just have to go to Data, Import Excel, and Matrices, because we have a matrix that we want to import, right? And then we select the file that we want to import that contains our network data. And then we can specify UCINET which sheets you want to import. And then this is important. We have to indicate that the first row of the file contains column labels and the first column contains row labels, which in our file they do. Now you have to pay attention here that our output dataset is going to be saved in our output folder, which we set up by default in the as a default folder at the beginning of our very first video series. And then this is going to tell us that the file that will be generated is going to be called own network. We click OK. And now you get your report in the text file, right? So it tells us, UCINET is telling you that it read this network data set, the file has row labels, the file was read with column labels, and the output data set has been saved onto our output folder, and the file name is called our own network. Here, it also tells us how the network was read. It gives us the report that the file had 4 rows, 4 columns, and 1 level. That means we have a 1-mode network. Now, for checking purposes, just to see whether UCINET did a proper job, we can try to visualize a network. And what we can hope for is that the network that UCINET is generating corresponds to the data that we fed, right? So we can follow the steps that we did in previous videos for opening a UCINET dataset in NetDraw. So we can go to Open UCINET dataset network, and ta-da, we see that own network double hashtag H has been created. We open it and we click OK. And this is what we get. Now, to see whether this network is correct, we can just simply double check with our self-collected dataset. So according to this, we see that John is friends with Frank. Do we see that? Frank is connected to John. That is correct. Then let's pick another one. Susanna is connected to John and Frank and Joyce. So it has 3 connections. Susanna indeed is connected to Joyce, John, and Frank. You can of course do this exercise for every single one of your node. This is doable for this very specific network. But in case you have a network for 100 individuals, maybe it's not something doable to go node by node. This is just to show you that indeed UCINET is reading the file correctly. Now let us go back to UCINET. So we have now been able to import our self-collected network from Excel into UCINET. The next step is to import our self-collected attribute data for our network, for our nodes into UCINET. Remember, our attribute data give us information about every single node in the network. Right now, our attribute data is a text file. It's in text form. So we need to convert that into a UCINET file. How to do that? We go to Data, Import Text File, and then select VNA. And then here we select what is our input file. This is our attribute file. And we don't want to generate a network for it because we don't have network data. We only have attribute data. So we have to select output attributes. And it's going to generate a file called attribute on network attribute. And that is okay. So then we can select OK. And now we can see that UCINET is reading different types of information. So it read information about gender. In the raw file, if I open it, the raw file data was collected as M for men and F for female. But UCINET prefers numbers, just like I mentioned with labels. If possible, you can use also numbers. So what UCINET is doing is assigning a code for the different values. So for UCINET, an M is going to be equal to 1, and a female will be equal to a 2. Then there is another attribute, attribute 4, and that is hometown. We had coded it by words as well, so Nijmegen, Amsterdam, Brussels, and Luik. And now what UCINET has done is it has generated a value for every unique hometown. Then age, which is another attribute we have collected, is just a number, so UCINET will not do anything about it. So the very last step in this report tells us how the attributes will be read. So this is what we inputted, and this is what UCINET is making out of it. So now we have to remember that 1 corresponds to a male, 2 corresponds to a female, and a hometown, 1 corresponds to Amsterdam, 2 corresponds to Nijmegen, 4 corresponds to Brussels, and 3 corresponds to Luik. Now, to check, we can go on our destination folder, and now you can see that the H file corresponding to the attributes that we just imported has been generated. So now we have an H file for attributes, and we have an H file for our very own network. Now, let's just put everything together into NetDraw to see how this network would look. So let's open the UCINET dataset for the network. This is how it looks. And then we can also open our attribute data, right? On UCINET dataset, attribute data, and then we can select the attribute file that we just generated, H file. And you have to make sure that node attribute is selected here. You're going to get a warning sign telling you that the attributes are going to be matched by the ID that you have in the attribute file and in the matrix file for your network. This is why I emphasize on the importance of making sure that you have the same number of nodes in the matrix as in the attribute file, and the IDs that you assign to your nodes is consistent between the network file and the attribute file. If the names are not consistent, then UCINET will not be able to match attributes to nodes. Click OK, and it has been created. Now, just like last time, we can go to our node tab, and then you can see that age, gender, married, and hometown are now characteristics, that are now attributes that we can use to modify the representation of our network. So just for illustration purposes, we can just say the male was a 1, and we want every male to be coded with red and every female coded with blue. We select that, and the gender should actually correspond to the color that we just selected. We said blue is for 2 for female and red should be for male. So you can now incorporate your data that you collected from carrying out surveys, for doing interviews. You can then transform it into an Excel file, as I showed you at the very beginning. And this Excel file has to be in the form of a matrix. And once you have this, then you can read the data that you have collected into UCINET to compute social network analysis. You can also use this information to calculate centrality measures, to calculate visualizations that we just did, etc., etc. So now you can go out, collect your data, generate and analyze your very own networks. So have fun.